Hello everyone, I'm Xiao Gang. Okay, let's continue with our basic concept. First, let's review the basic concepts of C++. So let's first talk about what programming thinking is. Actually, our programming thinking is mainly divided into two types. One is procedural-oriented, and the other is object-oriented. They are still quite easy to distinguish. Procedural-oriented means focusing on executing a series of basic instructions in a certain order. Object-oriented is about first assembling the object. We define both the attributes and methods, then we let each object execute. So let's give a simple example. For instance, if I want to wash dishes, then if we follow the procedural-oriented programming thinking, we would need to execute these instructions. For example, after putting in dirty bowls, add detergent, then start the dishwasher, rinse the dirty bowls, then wash the dirty bowls, take out the clean bowls. So this is the process of washing dishes. Now, what if I use the dishwasher to wash plates? Similarly, we put in dirty plates, add detergent, start the dishwasher, rinse the dirty plates, wash the dirty plates, take out the clean plates. And the procedural approach is this kind of one instruction followed by another instruction, a step-by-step interlocking way of thinking. Even if we just switch the bowls and plates now, all of these instructions of ours are all bound one-to-one and cannot be switched. So it means that the instructions here, these instructions in this place, are all different from the instructions below. If we use the object-oriented approach, we extract two objects from the whole process. One is me, and the other is the dishwasher. Then if we execute it this way, it would be, I put in dirty dishes, I add detergent, I start the dishwasher washes the dirty dishes, the dishwasher washes the dirty dishes, I take out the clean dishes. Similarly, if it's washing plates, actually, I put in the dirty plates. I add the detergent. I start the dishwasher, then the dishwasher washes the dirty plates. The dishwasher washes the dirty plates. Finally, take out the dry one. I take out the clean plates. Actually, in this case, you can see that instructions B and C are exactly the same. This is the idea of reusability. So, this example is meant to demonstrate the pros and cons of procedural programming. This is the procedural approach. Its efficiency is very high, but it is too random. It has strong extensibility, difficult to maintain. But the disadvantage of object-oriented, its randomness is relatively low, and it is easier to reuse, also easier to maintain. But the efficiency may not be as fast as this procedural approach. As quick, it completes with just one instruction, but if it involves multiple instructions that need to be constantly swapped, it becomes more complex. Okay, so this is actually a simple example. Just remember, we are object-oriented. We need to extract the properties and methods of this object. Properties determine what you can do, and properties determine what you have. Methods determine what you can do. Actually, there is a phrase we often say, which is everything is an object. What does this phrase mean? It means that many things in the world can be abstracted into individual objects. So there are mainly two characteristics. One is the object and its properties. He has his own method. Both are indispensable. Actually, how do we define the object of a human? First, a human has a brain in terms of hardware. They have limbs and 5 senses, right? In terms of abilities, they can sing, dance, rap, and play basketball. In short, this object is simply what it is and what it can do. This is object-oriented programming. Next, let's briefly mention the major characteristics of object-oriented programming. Let's give a simple example. For example, I have a level here. There is a level. I write some instructions in the level blueprint. For example, in begin play. For example, in the scene, I need to spawn an object. For example, you define a world like this. Customer 1. Let's not call it 1. Let's call it spam. Spam monster. For example, like this. Spawn a monster. Spam NPC then. The monster is hard to beat. Okay, then we might need to generate it like this. Every time we spawn an NPC, we have to execute this process. This is a procedural programming mindset. In the blueprint, you observe that each instruction is written out, and it executes them one by one. but this is inconvenient for us. So can we define an actor, define a scene object, and then this object is specifically responsible for spawning in this kind of scene, these NPCs, monsters, or bosses, etc. Then when I use it, I don't care about how many instructions it executed. Maybe when it spawns this monster, it will check if there are players nearby, if there are spawn points, the current game difficulty coefficient, if there are support points, and then spawn. But when we call it, we don't care. I just directly call the spawn monster method of this object. This method, I pass in an enum that I need. Then depending on this enum, it will take dozens of instructions. Classify and assemble them, and then select and execute them in sequence. But this is actually an object-oriented concept. Okay, then let's continue looking below. As for the major programming features of object orientation, you must pay attention to this. That is, if you don't know this, you won't be able to answer. That would mean the programmer hasn't even gotten started. You basically won't pass basically your object-oriented. If you didn't answer it, it's very difficult. So what are these features respectively? They are called inheritance, polymorphism, encapsulation, and composition. Then arrange them in order. Let's talk about inheritance first. Inheritance is actually very simple. Let's me give you a simple example first. Okay, I'll define an actor here, right? Let's call it NPs. Let's call it character. Or let's call it, let's call it book. Let's call it book. Then we define a subclass for it. We call it Tylis book. Then we define another subclass here. We call it English book, right? This is actually called inheritance. I think explaining this with blueprint should be very clear. So within this book, it has some variable attributes. Its subclasses can also inherit these variables and attributes. There is absolutely no issue with this, right? Okay, no problem at all. So let's continue looking below. Okay, so from the beginning, we define books. We can define them as textbooks, non-textbooks. So what attributes does a textbook have? It has knowledge at a certain stage. A textbook also has its category called a Chinese book, a math book, right? They all have paper covers, these attributes, but they are also different because maybe in our Bokta, it defines a book page. It has 50 pages. That is, my regular book has 50 pages, but its class, the Tylis book, has 200 pages. The English book only has 20 pages. This is inheritance. The benefit of inheritance is that the properties and methods allowed by the parent class. Then we can do something like continuously expanding in this way, thus reusing something. But inheritance also has some problems. That is because it leads to a deeper hierarchy structure. If it's embedded too deeply, it becomes very inconvenient, and my parent class has already defined this thing. So if you need to modify this thing, it becomes particularly troublesome to change. That is, your parent class defines a camera. You might not want this camera. Then removing this camera in the child class is especially troublesome, but in UE5, it is possible to do it. You can do such a thing in C++. We will explain it in detail later. Then we like to call the topmost class the Cypress, or top of parent classes. For example, in our blueprint, what is our top-level negative class? Our top-level negative class is this. This place was entered incorrectly. Actually, it's this one. We'll keep a brain cast. We selected all cast. You can see that all of us are derived from this object. Then, after the division, we have our pump. We have our character. Right? Actually, in the game, most things are actors. Your object is rarely used. Usually it's actor, component, pawn. This is something worth noting. So what is polymorphism? Polymorphism essentially means when we perform a certain action, different objects produce different states. For example, an elementary school student reads a book. They read an elementary school textbook. A middle school student reads a book. They read a middle school textbook, right? So let's continue using books as an example. If a book is read, it generates knowledge. If a textbook is not read, it generates knowledge at a different stage. If a Chinese language textbook is read, this generates linguistic knowledge. So the knowledge point we want to emphasize is that downward conversion is generally upward conversion as mostly successful. Downward conversion may fail. Okay, so let's talk about why we first draw a blueprint. Okay, so here we have a blueprint. Right. Let me save it for everyone. Okay, in the book, we have such a class. So actually, we do it this way. We still use the level blueprint for testing. Here we spawn a book, spawn an actor. Then we select book. Here we won't select book. We select this guess example, 台类似部. Then here, pay attention. If we promote it to a variable, the variable type will be tiles book. Then we set it to this. This can definitely succeed, right? Here, because we need to spawn it. Test it out. This place can definitely succeed. But if we now have a... Let me see. This is a pointer to tiles book. We call it tiles book PTR. Now let's paste it. Now let's paste a book feature. Then we set its type to this book. Okay, then we set it here. Okay, this is an upcast. This will definitely succeed. We'll use X to do this here. This is called upcasting. Then if we cast these two objects to BP. Book. Then write BP. There's no naming convention here, but it should be fine. Good. Okay, if we cast the book, it also succeeds. That's no problem. But now, here's the issue. If we in this place declare an English book, then we take this English book, cast it to book or directly set it to book. This upward casting is completely fine. But if we cast to tiles book, you will know that it fails. It fails. This is called downward casting. Upward casting always succeeds, but downward casting can fail. In other words, because we know that here we are generating an English book. It is definitely a book, and it is definitely an actor, but it is not necessarily a tiles book. That's what it means. Okay, so this is polymorphism. It's an explanation of upcasting and downcasting in C++. We also have overloading, overriding, unreal numbers, multiple inheritance, diamond inheritance, these C++ concepts. We won't elaborate on them here because this part is quite complex and extensive. We only cover the basic concepts here. So what is encapsulation? It means I do something. I put this. I hid all the detail inside. Hidden. I only exposed one function, only exposed one event and method. This is encapsulation. For example, if I now want to attack this monster, then I need to move. Then I need to equip a weapon. And finally play a montage, then encapsulate all the things inside these steps together. This is encapsulation. So encapsulation is very important. This is different from inheritance. Inheritance can lead to many layers of complexity. Composition is usually better than inheritance. So sometimes we don't want to use inheritance. We can use composition instead. Here is an example. If I want to learn efficiently, to learn Chinese knowledge efficiently, I could define a book called Efficient Chinese Knowledge or Super Chinese Knowledge book. In the same way, we can achieve this functionality. We could define a subclass here. We can definitely achieve this functionality. But we shouldn't do this because the hierarchy would be too deep. We should define another. We can define a component. We define an actor combo. When this actor combo is used together with an actor, then we cooperate by calling the methods of actor combo the properties in this book, thus achieving the function of efficient learning. At the same time, this actor combo can also be mounted on the ingani. It can also be mounted on other trees. So this is a concept of composition. The most common concept of composition. Actually, we can look inside the blueprint of this character. You can see these are the concepts of composition. Each component represents its own function. This is such a concept of composition. Good. Okay, so in this lesson, we have roughly discussed some basic concepts and ideas of C++ programming. We have covered them. So we will stop here for this lesson. In the next lesson, we will start entering the U++ system. Okay,